Let's look at this. Of course, we are using the product rule to simplify or to find the derivative. How do we know when to use the product rule? What's if the functions are being multiplied. They're not being added to one another. They're being multiplied to one another now. Okay? Now, folks, I need your attention. Those of you who are going with me, I need everybody's attention, period. But if you're going with me second semester, you definitely want to give me your attention. So this will be easier for you when I go through all of this in about 1 week. And that's it. And everybody else is going, what, Miss Perry? I don't know. And you're going to be the one going, oh, this is easy. Okay? Just get prepared. Okay? So we got two functions being multiplied, so we have to use a product rule, if you remember, just to have a line where you kind of got a formula to go by. When we find the derivative, it's the first times the derivative of the second, plus, what's the rest of it?
SDF.
SDF, what's that mean?
Second derivative of the first.
Second times derivative of the first, right? So what's the first function? Please pay attention.
X squared plus
3. First function is x squared plus 3. What's the derivative of the second?
3x squared minus 3.
Is that right? You guys agree with that? Okay. Plus, what's your second function, everybody? Right on. Times the derivative of the first. 2x. Well, that's not so bad, is it?
No.
Now, what are we going to have to do? What do you think you're going to have to do? Distribute that first piece of that function, and then what are you going to have to do at the tail end of this? You're going to have to FOIL the first piece and do what with that second? Say it again. Distribute. Folks, the more notes you put within your example problems, the more thoughts that we write down, the better off you're going to be when it comes time for you to work on this stuff on your own. If you don't practice it, you're never going to figure it out. Never. Never. Okay? So FOIL out that first piece. You don't need me to do that. Oh. X cosine x. You got to know how to find the derivative of cosine. What's the first function? X. Did y'all hear that? That's what y'all do to me sometimes. You roll in my eyes, you make it whatever. I don't even know what you call that.
I don't know.
X.
Little snappy, little snotty thing. Little spoon.
What did you say to
Negative sign of x.
Probably go, for real.
Right.
And she'd look at me and go,
I'm just
yeah,
thinking,
she's sassy. She's sassy.
She's
She's sassy, ain't she?
Oh.
Look just like her mom.
She's sassy.
She is.
We hate high.
Matt, we got
Cosine x. What's the derivative of cosine?
Negative sine x.
KJ, if you talk to me in that tone one more time. What's the second function?
Cosine
I
x.
might just smack somebody.
Cosine.
Cosine x. What's the derivative of the first?
Negative 1.
What's the derivative of x?
1.
Cosine x.
Just 1. Okay?
I thought you were talking about-
That's all it is. Because look, and make yourself notes. Here's your first. Here's your second. What's this going to hurt in your notebook? It is not going to hurt a
It's not
thing.
hurting nothing.
He ain't writing none of it down. Here we go.
I'm gonna write for you.
Listen, no, you're not going to write that for. No, ma'am. No, ma'am.
You need to write it down. That's an important
Look,
point.
look. You ain't got dog in that fight. Just let it be. Let it be. What's cosine touch? Shut your face. Shut your face. What is cosine x times 1? Cosine x. You are right. Is there any way to fix this? Turn them around and make it look better. Because I don't like negatives. Leading the front of the expression. Better not be recording.
Hey, that's really good. It is recorded.
Oh, Dang it, all right. Y'all just go. Mark nuggets, oh well. There we go. What do you think?
See, that just.
Look, y'all better not be in there, I'm recording
But
this.
you're not gonna use that one either, are you?
No, I don't care.
You should, that's good. You should.
Is that good?
Yeah.
Oh, this will be the one I got. I have 20 views on this video. Great.
You'll have more subscribers.
Oh, this is what's gonna cause you to, should I sing my notes every day?
Yeah.
Oh, okay.
It
That's what I
keeps
should
us.
do.
Get you more subscribers.
Okay, it's all about the subscriptions, y'all.
Yeah, 2 million.
Look, one last before we move on to quotient rule. Go. Go.
Okay, that's weird.
Hey, write this down. Thank you. Thank you. Now, this is the formula. Now, I don't know about you, but when I look at this, it's kind of like, what? Okay. It looks a lot like the original, but what's different? The product rule, we add, right? The quotient rule, we end up subtracting and dividing by a square. Do you think there's any correlation with multiplication and addition? Think about your exponent rules. Think about your expanding and condensing logarithmic exponential terms. It's all based around the exponent rules, folks. Okay? If you notice on product rule, we added. We multiplying two functions together. When we find the derivative, we add, right?
Mhm.
Quotient rule, we're dividing, but we end up subtracting. Folks, it just goes back to
That's just like,
exponents.
yeah.
If I said multiply x squared times x cubed, what would the answer be? X to the fifth. If I gave you x to the fifth divided by x, where? Top or bottom? On the top, right? Because now, do you see how it goes back to something we're familiar with? It's going back to these exponent rules. But the g of x, f prime of x stuff, nuh-uh. That is too much for me. So here's the way I'm thinking. Remember we went f ds plus s df, first times derivative of second. And I need that somewhere on my paper to go by. Here's the guide I would use for this. For the quotient rule, I will top and bottom. Okay? So here we go. G of x. That's your bottom times the derivative of the top minus what? Top times the derivative of the over
So it's bottom,
bottom squared.
so it's bottom, top, bottom.
Cool, okay, what? That's fast. You just said that really fast and my brain couldn't even process it.
Bottom, top, bottom, these four.
Bottom derivative of top minus top derivative of bottom over bottom squared. Now, do you just have to flat memorize this? Yeah, you do. You got to know how to use this formula or process. Okay? You ready? All right. DDT minus CDB over B squared. What? Well, let me see what you think about this.
I was just gonna say before we do anything, I don't think we should be fine with that.
No, not gonna happen.
That's why I said I don't know.
That's not gonna happen until we get all this done, because I want to have you to have time to work on this while you're in this class today. I want you to find the derivative. Find the derivative. Don't wait on me, y'all. You already have it.
One.
The top derivative of the bottom. Yep, no, bottom. You gotta work from the bottom up. I gotta remember that. In that song,
Bottom.
what's the song?
Bottom.
Maybe.
Bottom.
Okay, look at the formula.
Oh,
Bottom derivative of the top. So you start at the bottom, you work You go across and go back down. Aha!
So it's gonna be X minus 2.
Can I see the problem?
We was to write it out, fill it in.
I'm thinking, just thinking in front of y'all, okay?
Oh yeah, I remember.
Listen up.
You gotta put that, I tell you, the more you write that, the quicker it is gonna be for you to remember how to do this. And I hope you're paying attention to this and, figuring this out. So let's go, we got our top, we got our bottom. Folks, what's the bottom? X minus 2. Times, what's the derivative of x? 1. Minus x. What's the derivative of the bottom? 1 again. Over bottom squared.
It says like x squared minus 4x.
Okay, what are you doing? You're cleaning it up, right? Okay, that's what you gotta do. Anything times 1 is that thing. Anything times 1 is that thing. Can I clean that up? Can I clean that up? Yep. What happens? The x's cancel, so it's going to leave me with what? Negative 2 over the quantity x minus 2 quantity squared. Is that acceptable? Absolutely, it's acceptable. What's another thing we could do to that?
We could do it.
Fold it out. Fold the bottom. I don't want to do that. Okay? But know that. And put yourself a note. We could FOIL the denominator. And be prepared to see them FOIL. Okay? Are we good? So we got to start at the bottom, go to the top, minus top to the bottom, bottom squared. It's kind of a loop if you notice. Do y'all see how visual I am?
Yeah.
Okay, I hadn't looked at this. Find the derivative of that. Yes. Do that too. Hey, Jeff.
Oh, well, that big TTV, right? You're gonna have first term is 3 minus 5. You're gonna have that, write that down, and you put that in parentheses, and you got, you're not writing it down.
I'm not writing it
X
down.
squared plus 6.
Well, why?
Did you get a bottom?
Because my bottom function.
Oh, shit, I've been doing this backwards the whole time.
Well, hold on. Yeah, it is gonna be backwards. Well, hold on.
So flip your numerator to denominator. That's all you gotta do. You get that?
Mm-mm.
I ruined my whole day.
Don't let it ruin your whole day. Just fix it. Go ahead.
That's what I fixed in this
The
page.
derivative of the top is 3. Minus your top function is what?
3x minus 5 is 2.
And the derivative of the bottom is 2x.
So I
Now.
can get 2x, but you ain't get 3x.
Because the derivative of 3x minus 5 is 3. Because the power that you're starting with in the numerator is the power of 1. So 1 times 3 is 3. And when you lower that by 1, it becomes x to the 0, which is actually just 1. 3 times 1 is 0, is 3. Here, 2x to the first.
So basically, if I have power, I'm gonna use the x. If I don't have power, I'm gonna use the 1.
Yeah. Yeah, if you don't physically see a power there, yes. What about the bottom?
You just do x squared.
That quantity squared, right on? Okay, now, this is what may have bit you a little bit behind me, okay? Because you are subtracting that quantity, okay? So let's clean this thing up. Distribute, and I get 3x squared plus 21. You with me that far? That far? That much? That will make sense. Minus the quantity. This is the part that'll get you every time if you're not careful. When I go, hold on, let me do this. By the way. I'm gonna distribute here, I get 6x squared minus 10x, right? All of that over,
You have to distribute the negative.
right. That's the part people will forget about.
I just looked at it.
3x squared plus 21 minus 6x squared plus 10x.
You know how you, never mind. Just never. I'm just gonna have to always put stuff in parentheses. Like, I'd have to put the
Yes.
first one in parentheses too.
That's fine, that's fine, you don't have to. The only time that it's gonna affect your signs is if it's minus a
And
quantity,
it changes.
minus a bunch of stuff.
Okay.
That's when you have to be really alert and vigilant about changing your signs. What am I gonna do as far as like terms are concerned, y'all? My x squareds, 3x squared minus 6x squared is what?
Negative 3x.
Negative 3x squared. Then what?
Plus 10x.
Good.
Plus 21.
Plus 10x plus 21, all of it over that quantity squared. How about that?
I had that, but then my 10x was squared because of what I did with the,
Okay, because you got your derivative from.
yeah.
Okay, so that you know where you made your
Yeah,
mistake.
that's why
Okay. Is that what you had, or no? Good job. Yeah.
No, I did I just had both of them on the wrong sides. I did everything right, but I had I did top to first.
Okay,
Top
start at the
to
bottom. Start at the bottom, and then work your way up, over, back
That's
to
why
the
you were
bottom.
singing that song, I didn't even know.
I know, that's why I was singing this song. Now you know it, right? Can you do this on your own?
Yeah, I have.
Yes, you can. Okay, let's do another one.
It just
Hey, what have we not done? Yes, do you understand now why I've said all along, algebra ninjas? I mean, you have to be so, it's like your spidey senses. They ought to tingle every time you work these problems because you got to pay attention to quantities with a minus sign in front of them. You got to pay attention to making sure every like term is combined correctly. You got to make sure, am I doing the formula correct? Okay? And everything has to be like hyper alert because there are so many things that you can make one tiny little mistake and it's going to throw everything off. Okay? I don't want to do it. Here's another one. Sample 3.
Can you say hours?
Let's do it. You probably could.
40,
Not
100.
grammatically correct.
I don't know. That's a lot.
But I don't know.
What kind of notation is that?
Why'd you put the D of do that?
That's just, I need you to be
Oh.
aware that you may have other ways to determine the derivative. Find the derivative of x squared plus 3x plus 4, all of that over x squared minus 1. Work on this on your own with, yes, diligently, it's a good word. Work with each other. Make sure you're all on the same page.
Well, are we doing which one?
The thing I would have done different here, the only thing I would have done different is to have done this. Just because I am so aware that I am minusing a quantity. That's the only difference. Over the bottom square. Piece of cake, we got that. Okay? Now, the next piece, this first piece, she FOILed it out. 2x cubed plus 3x squared minus 2x minus 3. And the way she FOILed it out, it actually ended up being in descending order, which was nice. Minus, and then she distributed here. Okay? 2x cubed plus 6x squared plus 8x. Very good. Over x squared minus 2. That's x squared minus 1 quantity squared. And then she distributed the
I'm sorry I said Nancy. I was going so fast. I got so excited because I was right.
minus, that's correct. And then she put together those like terms. 2x, 8x, and that one's by itself. So the 2x cubed, stop. Cancel out. 3x squared minus 6x squared is negative 3x squared. You're combining negative 10x minus 3 over that quantity squared. Absolutely, that is correct. Very, very good. You have to be you got to be apprehensive. You can't make mistakes on your exponents. You can't make mistakes on your signs. It's going to throw everything off. And you can't mess,
You mess up the whole thing.
exactly. Okay? One more.
Do you see that?
And then I'm on, no, I didn't. Here we go.
No. I was asking KJ if he saw me do it.
Here we go. Let me show you what I've got right here. Another fun one. Oh, shh. Let's see.
I lost my pencil. My good pencil. My love pencil.
So where the be?
Did you still have a pencil?
You got to know the derivative of cosine. What's the derivative of cosine, folks?
Negative sign.
Negative sign. All right, so the bottom.
So you get that money.
Please write this down. Holy crap, I'm not going to answer your questions. If you're not paying attention, I'm not going to answer your questions. When I turn you loose in about 10 minutes, you've got to bottom, T cubed. You said the derivative of the top is, one more time, negative sign T minus, the top is cosine T,
And then 3.
and the derivative of the bottom, what's the derivative of the bottom?
3T.
3t squared, right?
Yeah, like,
What, this?
yeah.
So close the
Just close parentheses, just to show that they're being multiplied together. And then I'm doing these right here, Joy, because I know I'm going to subtract the quantity. Okay? I'm parentheses need you to. Okay? Over what?
T squared. I mean,
T cubed squared.
can you go ahead and add those two together?
Do I add them? It's a power raised to a power. What do I
You
do?
multiply.
You multiply them.
Right, that's what I
That's the way you're going to clean that up. Okay?
Okay.
How can I clean up that first piece?
Distribute the T cubed.
Yes, that's all it is. Just to clean it up, negative T cubed sine T. How can I clean up the cosine T times 3T squared?
Distribute the negative. Good, okay.
All right, minus 3T squared cosine T. And what do you do when you have a power raised to a power? You multiply it, so it would be T to the what? 6.
Yes.
I need you to, now, this is when I need you to look through your wide angle lens, and I need you to see the forest. So what? Why?
The camera.
At least T squared.
Derek, hold on.
Things like that.
Good. Derek, can you see it or no? You put your glasses back on, you can see. Say it again, Casey.
T squared out.
Of the,
Or negative T squared.
why?
Then let negative T squared.
Because I don't have anything against them, but what are they? Mathematically, it's GCF, okay? Here's what I would do. If you take out negative T squared, and you need to make yourself a note, GCF, okay? This is when I told you, this is when you have to look at the big picture, and we're cleaning it up. Now, let me ask you, is this right here an acceptable solution? Absolutely is. It is absolutely an acceptable solution.
I'd probably leave it like that.
But if it were multiple choice,
Could be a better solution.
there's going to be a better solution as an A, B, C, D, or E choice. So, negative T squared times what is negative T cubed sine T?
T.
T sine T. This is so weird.
Minus 3 cosine T.
Is it minus 3? Plus 3 cosine T. Now, go back and check it real quickly. Negative T squared times T sine T is negative T cubed sine T. That one's right. Negative T squared times positive 3 cosine is negative 3T squared cosine T. I'm good, okay? Over T to the 6th. Now, what can I do?
Take out another T.
Because if you know from Algebra 1,
It'd be sin T plus 3 cosine T.
what do you do when you have, you subtract the exponent, so it's 6 minus 2 is t to the who? Where does t to the fourth go? The bottom. So I'm going to cancel that out. I'm going to cancel the 6 and put a 4, and I'm going to rewrite this as negative quantity, because I have to keep that intact, negative quantity, t sine t plus 3 cosine t over t to the fourth.
Isn't there a...
What else could I do to it? I could distribute the negative back into it. That's correct. Or, could I throw it to the bottom? I could throw the negative to the bottom.
Either way.
Substitute more than
I don't ever want to, no. If the denominator is negative, that's fine. Doesn't matter. I don't ever want a radical if I can keep from it.
Okay.
Sometimes, though, at this level, we just let that go, because they're a bigger fish to fry than having to rationalize some funky looking function, okay? You gotta be aware of what could happen. I just want you to write this down so you'll know that it is another option, okay? F prime of t could be t sine t plus 3 cosine t over negative t to the fourth. Remember, think of negative signs that are standalone negatives, because that one is, okay? Think of them as being a floating negative. It can either be at the top, it can float to the bottom, or it can float smack dab to the middle. Like I could have put it right here in front of the fraction bar. But it can never be both places, top and bottom line, because then it makes it possible, right? So it can be either at the top, it can be at the bottom, or smack dab in the middle, but it can never be both places.
So you don't distribute it to the top?
You didn't, I could have, that's another option. Did you have negative t sine t minus 3 cosine t over positive t to the fourth? That is also an acceptable solution. Do you understand why this is going to take me so long to grade?
Yes, because you have to go...
There are so many different options, folks. And if you don't show your work, you are SOL.
So,
I'm telling you, you will be out of luck. Okay? You must show all your work. Have to. What time we got? Here we go. This is what's going to happen. You are going to work like a little bunch of dogs. Okay?
Hands on my wheel.
In a good way. I want you to work hard. Okay? I want you to work hard. I want you to look at page 147. And folks, this is what you want every single day in this class, is you want this time to go on and get started on your homework, okay? Because the more time you can work on this in here, with each other and with me, you're better off, okay?
We're gonna do 1 through 12.
No. I want you to work on the following. 1 through 3. Hold up. 1 through 3. 5 through 11. '20, '21, '23. '25, '29. '39. 41.
But no.
Now we have product and quotient rules, yes.
Is power rule in there too?
Well, yeah, but we always use power rule within those. Product and quotient rules, okay? Co-rattle wagons and get on it. You are to use your time wisely. If you don't, then I don't have to do this at all ever again. Just saying. But you want this time so you can work on